Okay, so I don't know what everybody said, but I'm Rob Sherwood. Been a ham since 1961. So we're going to talk about receiver performance, transceivers, contesting, you name it. So let me get you guys pictures out of the way. So performance now is so good, and this is good for all of us, that the limitation in a pileup, a de-expedition, whatever, may be the other guy's transmitter. So we'll talk about that. And why did I start testing radios? I didn't wake up one morning and say, gee, this is what I'm going to do for the next 40 years is test radios. But I had a Drake R4C and the reviews were good, but I used it in a 160 meter CW contest and the thing basically crashed. So the radio is what it is. So if the test says it's good and a CW contest says it's bad, well, the test is no good. So I wasn't real sophisticated then. I had a couple of signal generators that I could produce 2 signals on 20 meters. And I put the signals closer together, unlike the way it had been done since 1975, at 20 kilohertz, which was okay at the time for the design of the radios, but the architecture changed. And the league took decades to quit only testing at 20, and then it was 10, and then it was 5, and finally it was 2, just like I was doing. So the problem was, if the radio had a wide IF, if the first IF that was wide, like the R4C was 8 kilohertz, and then all the up conversion radios, like a Pro 3 or a TR7, if it was like 15 kilohertz wide or 20 kilohertz wide, then of course it was worse than 8 kilohertz wide. So when we were testing radios, the league and I, using the method designed in 1975, which like worked with a S line, it would be great. The 20 kilohertz number was usually up in the 90s for the more modern up conversion radios. But if you got the QRM in effect inside the roofing filter, well, then it crashed from 90 plus to 70, or maybe a little less, a little bit more, but basically 70. And 70 wasn't good enough for CW or RIDI, de-expeditions, pileups up to a CW contest or something, but it was okay for sideband, and I'll explain why that was. So in 1975, both Ham Radio Magazine, which I wish we still had, that was a fantastic publication, and QST defined noise floor. We'd had sensitivity for a long time, and that's a 10 dB signal plus noise to noise ratio measurement, usually in sideband. But then noise floor was done on a CW bandwidth. So if we look at back in time, R390A, I'm sure some of you have heard of that. It goes clear back to 54, sensitivity 0.2 microvolts, and the noise floor down there at minus 137. The R4C that started all this testing for me, 0.2 microvolts, and a minus 138 noise floor in CW. And then the K3S with the preamp on, because in the old days, everything had an RF amplifier, and it was a tube. But the K3S, you could turn the preamp off. And of course, a lot of modern radios today, that's normal. So 0.2 microvolts and minus 138. So the real problem today is local noise, urban noise. I moved to Denver out of college in 1969. And 50 years later, I would say on average, noise went up about 3 dB per decade, maybe worse at your QTH. Line noise seems like it's worse, not well maintained on the insulators and all that. Wall warts, everything, we have a charger for everything. And there are switching power supplies now. So they put out birdies. And of course, there are computers. Everybody has a computer, so switching power supplies. Household appliances have microprocessors, your dishwasher, washing machine, refrigerator. I know one guy said when I would transmit, the water comes out of my refrigerator as though I had a cup under it. LED light bulbs, some are good, some are bad. DSL, VDSL can make racket. And of course, if we're lucky, not here in Colorado, people are growing pot in their basement and they have these 1,000-watt light bulbs that make hash that can go for blocks. So in receiver performance, well, Orion 1, the Ten-Tech Orion 1 started a new trend. And guess what? They did something old. They quit having up conversion radios, which means the first IF is above 10 meters or above 6 meters. They went back to 9 megahertz or something like that in other radios, like between 5 and 11, like a TS590 is 11. So Elecraft came along, and then 2008, that's the first time I saw it. It might have shipped in late 2007. And so they really carried on this trend, and in a way they kind of ate Ten-Tech's lunch. So the receivers today are just amazing, and we'll see a chart near the end that shows what today we could just would have dreamed about decades ago. So what do we have today? We have this hybrid superhet and the direct sampling. And hybrid superhet simply means it's a superhet radio with a direct sampling band scope and a direct sampling waterfall, but otherwise it's a superhet, and it's got a roofing filter. So the other thing that was defined there in 1975 in QST and Ham Radio magazine was dynamic range, and that basically said how strong signals, 2 or more, can the receiver tolerate before it starts generating its own interference, and the interference level we're going to define as the noise floor. So that's your spurious free dynamic range. However, sometimes there's other spurious, and likely it's not going to be a problem, but sometimes you'll be tuning around and, wow, there's some spur that's way worse than the third order dynamic range spur. But for the most part, we're looking at the typical third order dynamic range, just like if you look at a amplifier in QST and it has third order products, then fifth order and seventh order, usually falling off, hopefully. But so the third order product is what we're looking at to make the dynamic range measurement. Now, for years though, the synthesizers in our radios weren't very good. I mean, when we go back to a Drake or a Collins or whatever, they had a PTO and a crystal oscillator for each band. Really didn't have much trouble with noise, wideband noise. I mean, there's some noise, but just really insignificant. But then once we got synthesized radios, which we liked, they didn't drift, they had a digital readout, probably had general coverage, but the synthesizers were basically terrible. So in 2012, sort of after much complaining from my end, that we need to consider this because this may be the dominant factor. So reciprocal mixing dynamic range, dealing with the synthesizer, or now with a direct sampling radio of the clock, we really need to measure that. So I'll have some numbers on that and explain that in more detail. So as I was saying, with the wide first IF filter, the dynamic range was much less. I mean, if we're going to test at 20 kilohertz, that implies the QRM will be down the band 20 kilohertz and 40 kilohertz, or up the band 20 and 40. Well, that's not your typical pilot. Now, when we have a narrow roofing filter like a K3S or the Kenwood 890S or the new Jesus, well, you could theoretically get 2 signals besides the one you want to listen to inside that, but probably the limit then would be somebody's key clicks or transmit noise or something else. So in practice, if the roofing filter is about the bandwidth of our final DSP selectivity, then we're not going to be in an overload situation. We're going to keep 99% of the signals from going downstream, which what was happening with the 15 kilohertz roofing filter. We could have 100 signals in there. And then of course, you got the direct sampling from Apache, the Elecraft K4, which has now been actually at regular customers now for about 11 months, the Flex and the Icon. By definition, the direct sampling radios have no roofing filter. So when we measure the dynamic range, it doesn't matter at what spacing we test it, which in one aspect is good, another aspect, it's a weak point, which I'll discuss. But really all the direct sampling radios pretty much are around 100 dB, pretty nice number. So the superhet does have an advantage in some cases. Really strong signals, usually line of sight. I don't think I've ever seen an S9 plus 60 skip signal, but you can have a guy a mile away or at 160 with ground wave, he may be several miles away. So in this case, from a a blocking standpoint, the roofing filter has an advantage, and certainly on field day. Of course, we have to also worry about reciprocal mixing dynamic range and transmit composite noise. But from just a straight blocking standpoint, the roofing filter has an advantage. If we look at the numbers, a K3S, if you look at my website or even what Elecraft likely publishes, it's about 150 dB, where the direct sampling overload point typically around 125 dB, some about 5 or 10 dB less. But you're probably not going to be able to realize that 150 number, because that's done with a super clean signal generator that's likely cleaner than a real transmitter, but it's still an advantage. Now in field day, or certainly a ham close by, we've got to say, what is this ADC, analog to digital converter chip, seeing? It's not just seeing signals in the ham band, most likely. For instance, once we got general coverage, most radios use a half octave filter, and that can be quite a few signals outside the ham band. Like on 20 meters, the front end filter, LC filter, is about 11 to 15 megahertz, or maybe 11 to 16 on the ICOM examples. So that is going to put a lot of signals into the ADC chip that aren't even in our band. Now that's the case where a tracking pre-selector can help. The Yaesu has it, the 7610 has it, the Yaesu 101 and the 101D and the 101MP, not the FTDX10. So the pre-selector can be helpful. Now it might be helpful on the low end of 40 meters, for instance, on CW. If there's a broadcast station like 7.25 megahertz, well, the pre-selector in the ICOM would knock that broadcast station down about 10 dB, and probably the 101D a bit more than that. But for the most part, our ADC chip is looking at a lot more than we'd really consider. So you say, well, okay, well, why isn't what we might say almost perfect receiver adequate? Because we have to deal with wide signals that are in our DSP side passband. And that wide signal may be sideband splatter. We've certainly all heard that. If you're a CW operator, you've heard excessive key clicks. And then broadband composite noise, that means phase noise plus amplitude noise, those combined to what we call composite noise. So I'll give you two examples that are just excessive. It was the AWRL 10 meter contest a year ago, and well, 2020. And there was one CW signal that had key clicks 35 kilohertz wide that I was able to copy. And I found the guy. Of course, I just had to keep tuning till the key clicks got worse and worse. And I wrote his call down. There was another guy that had really wide noise that was 50 kilohertz wide. I found him also. And when I finally found the signal, he not only had all that noise, but he had like 8 additional CW signals that were spaced out some fairly consistent amount, like every few hundred hertz, and falling off an amplitude. But the guy had 9 signals on the air. So who knows what was wrong with his rig. So what has improved recently? Well, the phase noise, the reciprocal mixing dynamic range has definitely improved. But because that improved, it generally improved the transmitter noise. So that's really good. In a superhet, we'll look at the K3S. If you had a K3, hopefully you upgraded your synthesizer. The 7851 is kind of expensive, but it was good, of course. And then all the new Yaesu, the 101D, the 101MP, and the FTDX10, little brother, have very good transmit noise. And then from a wider offset standpoint, the direct sampling radios, well, the TS890 isn't quite as good close in, but it's virtually identical at 100 kilohertz. Same with the 7610. So if you're on CW and the guy nearby is on sideband, up the band 100 kilohertz, probably not going to bother each other. So the direct sampling radios, right now we've got the Apache, the Flex, of course, has been around a long time, the ICOM a few years, and the Elecraft, just like I say, from a real customer standpoint, just under a year. I do want to compliment Yaesu because they were kind of the notorious for lousy transmit noise and lousy key clicks. And W8JI has complained about that for a long time, but they've really got their act together now. So a tip of the hat to them. Okay, this reciprocal mixing dynamic range or phase noise, what are we talking about? We don't listen to our local oscillator. We don't listen to the clock in a direct sampling radio, the clock meaning a crystal oscillator. But let's look at this little bullet nose signal on the left, and that's the weak signal, and it's, it's DXCC number 100, or it's a multiplier, or whatever it is. But they're put a strong signal nearby. It could be a perfect signal, not that that exists, but even if it was, it doesn't matter. Every oscillator has some level of noise. So the noise sidebands on the local oscillator mix with this nearby signal, and nearby can be relative, and it puts noise sidebands. So if you look there on the right, the noise sidebands got transferred to the strong signal and can cover up the weak signal. Well, this shows a case where the noise is falling off like a Gaussian pattern, but there are some rigs where the noise doesn't fall off at all. Whatever it is at 10 kilohertz, it's just as bad at 100 or 200. So in that case, the nearby signal could be up the band, 200 kilohertz. Of course, that would really annoy me. So let's look at some contests and how I operate my radios in a contest and what I might recommend you consider. So this was December 2018, the ARRL 10-meter contest. If you're working in both modes, CW and sideband. So this was the bottom of the sunspot cycle. So there were lots of signals. There were over 20 signals in this screen capture in a 10 kilohertz bandwidth. But the thing to look at is how was I running the receiver? Well, I had the preamp on, upper right, and I had the audio peak filter on. And so in my case, I'm out in the country with good antennas in a quiet location, but how do you know when to turn your preamp on? Maybe you're on 20 or maybe you're on 15. So when do we turn it on? We don't want to just say, well, if in doubt, turn your preamp on. And certainly I've talked to people who turn their preamp on 40 meters at night, which is crazy. So what we want to consider when we're trying to deal with how to work our receiver, how to operate a receiver the best way possible, is considering antenna noise gain. It would be nice if you had access to your dummy load at the flip of a switch, either a spare port on your rig or an alpha delta antenna switch, and you put your dummy load on there. So what you want is to be able to switch between your dummy load and your antenna tuned in between stations. And the band noise should go up noticeably. Now you can measure it, and I'd like to see 6 to 8 to 10 dB, but you don't need to measure it. I mean, 6 dB is pretty obvious. So if, for instance, you were on 10 meters and you switched between the dummy load and the antenna, and you could barely hear the antenna connect, turn on your preamp. On 6 meters, I've never had a rig yet out at my quiet location where going between the dummy load and the antenna would go up 1 dB. You could hardly hear it, maybe not even notice it at all. So for sure you needed the preamp on 6 meters. Now here's the week before, in December 2018 on 160, again, the ARRL contest. Well, let's see, in the middle upper portion, we've got an arrow there to the audio peak filter, just like I was running on 10 meters, of course. Over on the left, preamp is off for sure. I've also got the attenuator on. So why would I do that? Well, there's 2 reasons. Remember the fact that band noise varies by band. So if we look at band noise, typical band noise in a quiet location on 10 meters during the daytime, and compare that to band noise at night on 160, the difference is approximately 30 dB, 30. Well, every radio's got enough sensitivity, noise floor for 10 meters or 6 meters today. So we've got sensitivity to burn. So to reduce the possibility of overload, maybe you've got a ham 3 miles away that's 70/9. So you put in attenuation. Well, if you would punch in 6 dB, I'll almost guarantee on 160 that you're not going to hear anything change. So you can tune between stations. Band noise is reading upscale on the S meter. You put in 6 dB attenuation, the band noise doesn't drop. Maybe it starts to drop at 12. That is one advantage of the 7610 and also the K4, that you can pick 15 dB attenuation. So if the band noise has dropped a noticeable amount, this helps with what I call contest fatigue. Whether you're running and in between stations you're working, you hear band noise, or if you're a search and pounce operator like I am, every time I tune between stations, if band noise is just as loud as every station I work, that just fries my brain. So you really want your AGC threshold to be above band noise. Now that adjustment is different with some radios. I mean, I'm using an attenuator in this example, but the Flex, for instance, has a slider that adjusts AGC threshold. The Apache has a horizontal line that you move up and down with your mouse that adjusts AGC threshold. It's just different, but it comes up to the same effect. But here was something interesting. I'm usually trying out a new rig, sometimes two, but I didn't have anything in December 2018 that was new. So I hauled out my 7300 and a TS990, and I said, let's compare these. Vastly different radios in price, size, features, but I'd run the 7300 many times and it works okay. So let's really A/B the two. Well, to make it fair, you have to set the attenuation the same. Well, the 7300 has one attenuator, 20 dB, period. I wish it was 10 and 20, but it's not. So the TS990 was set at 18, which is as close as I could get to 20. And I operated the entire contest with that much attenuation. I had never done that before. I loved it. It was a little bit more than I was used to. I did have to turn up the volume control a few more percentage of the time. I'd say before running 12, whatever, 3% of the time or something really small. But every once in a while, I'd be working a signal that was below the AGC threshold. But with the 18 dB attenuation, maybe I had to turn it up 5% of the time. But in between that 95% of the time, the noise was almost gone. Not entirely, of course, but the fatigue factor was a massive improvement. So ever since then, I've tended to do more than less. The other thing, when I took this picture, and the only reason to take it initially was, look how much QRM there was compared to 10 meters. I mean, in 10 meter, look, we got 20 signals, but they're all kind of weak, bottom of the sunspot cycle. But here we got lots of strong signals. But what did I notice? Over on the left is a signal that's I call key clicks 5x. In other words, he's 5 times as wide as he ought to be. You can see how bad his key clicks are on the band scope. You can see how bad the key clicks are on the waterfall. But then if you look over to the right, now there's a signal that might be at most 3 dB weaker. Look how narrow, where it says clean on the right, how narrow it is on the band scope, and look at the waterfall. Boy, it just knocks your socks off how narrow that guy's signal is. So he's being a good neighbor, sharing the band with everyone else compared to the guy on the left. But look even more closely, look at the little blip that's in the key click range of that signal. It's sticking up, 5 dB above the key clicks. And you can see that in the band scope, and you can see that in the waterfall. There's some dots in there. So it'd be harder to work that guy because he's getting buried with the key clicks. So we shouldn't be doing that. And often we can turn that on or off with an adjustment on our rig, and we'll get to that. So we looked at a CW signal this wide on sideband today. We don't really have as clean a signal as we might like, except for Apache with something called pure signal or pre-distortion that cancels out the distortion products to a large extent. So if we look at the signal on the right, you can see that pure signal, that's an Apache. The signal is just a rectangle, straight up and down. We look over there on the left, there's a signal that you can see the splatter sidebands. Now, if he was S6 or something, you couldn't see it, but he was a strong signal. But this is typical today of most all rigs, that the splatter sidebands Admittedly, they're down like maybe 30 or 40 dB at times, but there is total signal width is 3 times what his real desired bandwidth is. Now, in this case, the pure signal was an ESSB guy. He liked the 4.6 kilohertz bandwidth. I can't even hear that wide with my transceivers. I wouldn't run it that wide. I'd run it, 2.8 or 2.7 or whatever. But the point is, it's a rectangle and it doesn't have the wings like the one on the left. I didn't, to try to keep the length under control, I didn't include some spectrum analyzer shots. I've got them if you want them later, or I've sent them on to your club. But the cleanest transmitter that I've owned and had on the air is a Collins 32S3. 6146 finals, negative feedback, just like in audio amplifiers. On the other hand, even cleaner than that are the Class A rigs, but they're gone. The 1000 MP Mark V, the 5000D. For some reason, the new Yaesu 101 MP could have had a Class A. The Class A rigs pretty much required a 200 watt rig. So in Class A, they were a 75 watt rig. There was the Mark V Field, was a 100 watt rig, so it was only a 35 watt rig. So that wouldn't drive all the amplifiers. But the strange thing was the ALC in these Yaesu rigs that had Class A was totally designed wrong. When I complained about it, they said it makes us louder. Well, that's true. If you're going to go to the trouble to have Class A and a super clean signal, don't run any ALC with your older Yaesu. Pete W6XX, unfortunately no longer with us, but he had an outstandingly clean signal. Barefoot, Class A, but then driving an 8877. And so he was basically as clean as my Collins was. And then we have the Apache with pre-distortion. Flex has talked about it for like 10 years. Elecraft says the K4 will have it someday. Let's hope so. If we could get 3 companies out of the main 6 that had pre-distortion, this would be great. And it would pressure everybody else. So back to this key clicks that you saw in the screenshot. You'd hope you could work a weak guy a kilohertz away from a strong guy, but that's going to depend on what rise time the operator selected in his menus. Virtually all the new rigs have a rise time adjustment, for good or for bad. Unfortunately, they offer choices that you shouldn't even have as an option. So here, look at the difference in the key clicks at 1 kilohertz offset between a 1 millisecond rise time on this case, the 890S versus 6. And that's the range you can pick, 1 to 6. 25 dB fewer key clicks, 25 dB less key clicks there at 1 kilohertz offset, just by selecting 6 milliseconds instead of 1. So we need to be a good neighbor. So get rid of these really fast rise times. And I compliment Yaesu again. You can no longer pick 1, 2, or 3. I wish that ICOM and Yaesu and Kenwood would do the same thing. So, okay, what's rise time? What's he talking about? This is in the time domain. This happened to be a 10 tech. Its range of adjustments in the menu was 3, which I wouldn't pick, to 10. Maybe wouldn't pick 10 either. But look at the rise time on the left, how quickly it goes up. So that's what rise time is about, is how quickly it goes from key up to key down full power. The faster it goes up, the wider the key clicks. And on the right, well, that's really slow. So I'd probably pick 8. And so that's what it looks like in the time domain. I mentioned this composite noise. That's AM noise added to phase noise. And so this is an issue when, particularly line of sight, when you've got signals that are really strong. So here's 3 examples of vastly different transmit composite noise measured on 20 meters. Now it's measured in dBc per hertz. Don't worry about that. Let's just look at numbers. Big numbers like -141 for the K3S at 10 kilohertz, that's tremendous. At 100 kilohertz, it's also tremendous. It only improved 2 dB because it was so good to start with. If you look at the FTDX10, if you look at the IC7610, the ICOM is not as good at 10, it's -128, but at 100, it's virtually identical to the K3S, -142. Then we can look at the FTDX 3000. And that's one where it's flat. The phase noise, transmit noise characteristics does not improve with spacing. So at 10 kilohertz, it's the worst of these three. And at 100, you can see it basically didn't change. And I could have measured it at 200. So that's going to cause troubles if you've got a nearby signal that's really strong. So to give you a real world example, in Boulder, Colorado, some of the hams are up in the foothills. So this one ham is up there about 1,000 feet above the city. And one of the hams in town, in the city, 1,000 feet lower, has a stack on 15 meters. And when the gentleman up in the foothills had a 1,000 MP, he never bothered the guy with the stack in town that was 5 miles away because of the elevation difference. But when he switched to an FTDX 3000, it basically wiped out the 15-meter band. So my friend Ken N0QO went up to the offending transmitter and made the measurements. So we know this is right. So that I've got data on several rigs, like more than about a dozen really, talking about this, and that can be available if somebody would like to see the PDF. Did you read my article in November, QST of 2019? The league initially asked me to write something for QEX about composite noise. I thought, well, that's not the whole story. We got key click noise, we got splatter noise, and we got composite noise. So I wrote the more expansive article, and they said, oh, we're going to put it in QST. I thought, wow, cool. So they came up with the title, It's Time to Clean Up Our Transmitters. Amen. Our receivers are amazing, but we haven't made progress in the transmitters for the most part, and in some cases gotten worse. So if you've got your QST around, take a peek at it. At the same time, they were testing the Expert amplifier, 1.5 KFA, and the third order distortion products measured in PEP. That's the way they publish it today. I wish they didn't do it that way, but okay, that's what we've got. It makes the number 6 dB bigger than the real measurement, but okay, we're just going to compare PEP to PEP. Well, pure signal in the Apache improved it 17 dB, making that nice rectangle signal. So there it was in the same issue I was talking about. Splatter noise, we saw a way that we really could see a significant improvement. Back in 1997, the league published a compendium of tube-type linear amps, which is pretty much what we had in 1997, and everyone was down minus 40 to minus 50 dB using the PEP method. Well, in QST, they tested the KPA 1500. It's an LD MOS amp, the intermod minus 30, which is 10 or 20 dB worse than a good tube amp. Not a sweep tube amp, a good amp. The Flex Power Genius has been measured here in Denver by N0QO. On 20 meters, it was minus 30, a little bit worse on 10 and 6, and a little bit better on 40. The Expert amp that we just saw out of QST, minus 30. This is pretty much what all the LD MOS amps do. But when I had my TS990, that distortion was minus 40. It was a 50 volt PA. It was significantly cleaner than most amps, most transceivers, and with their 13 volt amp in the transceiver is just not as good as a 50 volt amp. So if I'm going to transmit through an LD MOS amp and I've got a cleaner transceiver, then it's not going to be any different than anybody else's. So here's a couple graphs from QST. I wish they do this all the time. The Elecraft amp is on the left. In this case, this is the input-output curve. You wish it was absolutely straight. That would be perfect. But it's pretty straight up to a kilowatt, and it flattens off a bit. It's the blue line. It flattens off a bit at 1,500 watts. So I'd probably run the KPA 1500 at a kilowatt on sideband. CW, FT8, ready, no problem. Run at full power. But here was the ACOM 1200S, and this also applies to the 600S. But in this case, the 20 meter graph input output is in red. So it's pretty straight up to 700 watts, and then it almost goes horizontal. Well, not quite horizontal, but way too horizontal to suit me. And they actually published the data in the review at a kilowatt, and at 500 watts. And it was much, much better at 500 watts. So if you do happen to have the ACOM 1200S or its little brother, the 600S, consider running it at half power. So you can be a good neighbor because we share the bands. So the bottom line today, performance of the 6 major OEMs is amazing. And the limit may be the other guy. So the challenge is now is us, the consumer, what are we going to buy? I mean, competition drove the improvements from like a 70 dB radio. That's pretty much what we had for 15 or 20 years until we had 100 dB radios kind of in the middle of the pack. The other thing is the OEMs finally learned how to design clean synthesizers in an affordable radio. So this was tremendous. So now we need to say to our OEMs, we want a clean transmit signal. Now, some people argue, I'm a contester, I want to be 10 kilohertz wide, but give me a break. So here's some information off my website with the top 20 rigs, not in the list 1 through 20 because there's duplicates. Why is that? Well, the K3 came out in 2008. Then the K3S came out. There was also an improved synthesizer in the original K3. That's there. The direct sampling radios, there's more variation from unit to unit. So there's like second samples for several radios. So this is the top 20 individual rigs going from 110 to 90. You should be able to be extremely happy depending on whether you like the radio run with a computer, you want a big radio, small radio, inexpensive radio. You can just do extremely well with all of these. For instance, the 590SG, N2IC, big contester, Steve London, used to live in Denver, now lives in New Mexico. He has a pair of 590s. Those are like $1,440 brand new. There's 3 radios here I've got little asterisks. We're going to talk about those in the specific, the FTDX10, the K4D, and the ICOM 7610. So from a rig comparison standpoint, I never got to operate the 101D on the air. It passed through my lab before Contest University, the last time we had it before Dayton, before COVID. It went to California to get the overshoot fixed. It came back, checked the overshoot, went back to its owner. So but there really, some of the input I'm going to give you on the FTDX10 would be similar on the 101. So price is kind of amazing here. The K4D is kind of pricey. If you include the tuner and the double receiver, it's almost $6,000. The Yaesu FTDX10, pretty much a bargain at $1,400 with some compromises on ergonomics. I'll talk about that. The FTDX, the ICOM 7610, this is kind of the sweet spot in radios today. You get a lot of radios today for around $3,000, $2,800 to $3,200. That's kind of the sweet spot. And the 101D there, it's the same price. Right now, you can order a K4 or a K4D. The performance of the K4 was as expected. Almost all the direct sampling radios have a dynamic range, about 100 dB. And the ADC overload point is pretty much like we'd expect it, just about 3 dB higher than what I quoted as the average. And we can kind of look at a K4 as half a 7610, meaning you can do 2 bands at once, like 160 and 6 meters if you wanted to watch for a 6 meter opening. But the front end LCD filtering would go broadband. In other words, it would just go away. Now, I'm not talking about integration features with the KPA 1500. I'm just talking about basic operation. And then the K4D, the architecture, pretty much like a 7610. 2 independent receivers, 2 sets of LC front end filters. So if you want to be on 160 and monitor 6 meters or whatever, you don't have any compromise there on the front end filtering. Now the K4 HD, we have no idea when it will show up and what it'll cost. It would offer to have some extra performance because of roofing filters like the K3S. Each receiver can have up to 3 filters. So you might have 6 if you had the K4D, which really you have no choice. You can't put an HD in a K4. You can only put an HD module in a K4D. So I've got to see K4D in May of last year. And Ken and 0QO and I spent weeks testing it in the lab and listening to it and using it on the air, but at that point, not in a contest, which I'll cover in a moment. But there were issues with, well, it's software. I mean, almost everything today I'm going to call is a software-defined radio, even if in the vernacular that's not used that generally, but there's software everywhere. So there were bugs in the AGC, the CW timing was screwy. There was distortion initially in the audio that's been improved. The transmit audio had issues with the EQ. So there were lots of things, and all this data was sent on to Wayne, and they've been plugging away at it. So it's updatable. You plug it in the internet, and you can update the firmware. So I finally did get to operate the K4D and 2 contest in December, just this past December. So as usual, I run the ARRL 160 CW contest, the 10-meter CW and sideband contest. At this point, it had been updated to firmware R26. I ran into a problem with selectivity on CW. I'll cover that in the next slide, but the DSP issue is nominally scheduled to be improved, or at least an option. Current software type of filtering, or the sharper filtering with R29. I don't believe that's shipped yet. The transmit EQ was all screwed up. It was what you put on the sliders was off by a factor of 4. That did just get fixed with R28. There was also completely inadequate audio gain, particularly if you adjusted the slope of the AGC, and that did get fixed in R28. I had this strange thing, though, happening there on 10 meters just before the contest. I was talking to N0QO, who was about 50 miles away, and I set the volume at a comfortable level, and he quit talking, and the band noise was louder than when he was talking. And he'd talk again, it'd be comfortable, and he quit talking, and the band noise was louder. I have no idea what's going on there, but we reported that to Wayne. So this is the key of everything today, is software upgradable. I find a mouse is very helpful with the K4D. That's a personal choice, but I'd rather do that than have to reach up and poke in the screen. So I'll evaluate the software firmware again in May, which will have been a year out from the first time that I ran it through the lab and did basic testing, and the numbers that are up there on the website. I doubt the numbers will change, but obviously all the features and bugs and stuff like that, we'll hope that in May that a lot of these things will be spotted. So here's what I ran into in the 160 contest. I was working a weak station that was 90 hertz away from a strong station. And usually in that case, if you've got the selectivity set, in this case for 100 hertz, I wouldn't hear the station 90 hertz away except maybe his key clicks. But he was right there, like he was going right through the filter. So I stopped in the middle of the contest and measured the bandwidth. And I compared it to a 7610 because I've got 3 operating positions. I had them both set up with N1MM. I could just switch chairs, tune in the same station, and I had no trouble working the weak guy. I didn't hear the other guy with the 7610 set for 150 hertz bandwidth compared with this K4D at 100 hertz. So if you look at the selectivity I measured there, right in the middle of the contest, at minus 40 dB, well, the bandwidth of the K4D was like 410 hertz, and at minus 40, at a wider nominal bandwidth, the ICOM was at 210, basically half. So I reported that on the reflector, like within a day or two. And amazingly, after I said that, 4 people chimed in and said, we'd just run this, the CQ Worldwide CW the week before and noticed it, but no one took the time to measure it, or maybe they didn't have the equipment to measure it. So that no one had mentioned it. And that was just a head scratcher to me because the radio at that point had been out for like 10 months and no one had complained about the CW selectivity. Anyway, it's slated to be fixed in R29. So let's hope so. Here was the other thing that was strange is the audio rolls off. This is sideband, and the wider the bandwidth, the more it rolls off. But this was like 2.8 kilohertz. There's like an 8 dB roll off of the frequency response of the audio. Now that reduces clarity because you don't want the sibilant sounds, the higher frequency sounds, the 2 to 2.5 to 2.8 kilohertz voice sounds to be reduced in amplitude because you'll lose clarity. Wayne's played with that. It's a hardware issue. He's played with it a little bit, but I haven't heard much about it for a few months. Let's look at the FTDX10. I did get to use this. The lab numbers were pretty amazing for a radio at $1,400. Just a little bit below the 101D. To me, the ergonomics are kind of clumsy. For instance, the volume control is just to the left and a little bit below the center line of the PTO. So I turn up the volume and I hit the tuning knob with my knuckles. But if they put it over on the right, where like the notch filter is or something, that wouldn't happen. Most of us are right-handed, so I don't understand why they put the volume control where they did. Major updates in firmware, as I say, software-defined radios today. The May update was major. There was also one in April, which got part of it right and a couple of bugs. So May is the last one as I'm aware of. Key collects are no problem anymore. Wonderful. I measured both the 101D and the 101MP. Tremendously narrow, great. The funny thing is they advertise the 3D waterfall as a big deal. What is a waterfall? At least to me, I can see what's been happening for the last 30 seconds to a minute. I hope that the waterfall gives me the option to last almost a minute because I want to be able to tune around like on the 10-meter contest just recently. The station, I need to be able to give time to work one and go tune in the next guy. So anyway, with the 3D waterfall and originally the 2D waterfall until the April update, as soon as you'd send one DIT or you said hello, the waterfall got wiped out. Well, what good's a waterfall if all the data that you've been collecting for 30 seconds or a minute goes away? So anyway, they fixed the 2D waterfall on the 101D and the 101MP and the 10. But the 3D still, all of the data goes away if you transmit. And I'm told by Yezu out of the UK that that can't be fixed. I have no idea why that would be. I really like a mouse with the 10. So that again is a personal choice. So some of these limitations are coincident with the 101 and the 10. So I did operate it in CQ Worldwide 160 CW a year ago. I had a little over 200 Qs, only operated one day. I was search and pouch. I worked 3 JAs, so there was no trouble there. 45 sections, which would be US sections and Canada provinces. Like I say, it was only on the air for 7 hours. The selectivity was fine. APF, audio peak filter, was fine. I changed the default. I didn't like it quite as narrow. That's your choice. You can adjust it. Ever since the 101D came out, people have been complaining about the band scope needing averaging because it's kind of jumpy. It kind of makes your eyes jingle. So excluding the ergonomics, which I wish there was a more space, but of course the 101D and the MP are bigger, so you don't run your fingers into the tuning knob so much. I did find the mouse was very helpful with the 10. You may find it helpful on the 101D or the MP. The 10 has really noisy TR relays, and the tuner takes forever to tune, and it makes a lot of racket. So I guess if you're dozing off, hit the tuner. Comments on the 7610. CW selectivity is fine. As I mentioned, that was my reference, comparing it to the K4D. It was like half the bandwidth of -40, set wider than the K4D. But like I say, that's going to get fixed. It's easy to adjust the default bandwidths. There's 3 default bandwidths. You can just hold in the bandwidth button and set them whatever you want. I happen to use on sideband 2.8, 2.4, and 2.1. Your choice, whatever. CW, 500, 250, and 150. Whatever you want, you can pick it. And you can adjust it, of course. The AGC decay times are very easy to adjust by mode. So you can adjust that to your liking. I like fairly slow. Others may not. And if you're running, maybe you want it faster. The TR switching is solid state. The amp key line, if you have a modern amp, that can be solid state. And if your amp has pin diode switching, There's no noise, just silence. It's just wonderful. But the 7610 has really flaky drive gain adjustment, which you use to adjust your ALC. You even have to hit a separate mechanical button to adjust that. So there is no markings on the ALC. So I just use the S meter. Don't go below S3 or the output will crater. I kind of shoot for a 5, but the default's like 8 or 9, S9, S8. So that's kind of funny. And if you want a separate knob for the second receiver, guess what? You got to buy a $300 external knob. So I was able to buy them used. They were only $200, but you'd think you could sell one cheaper than that. But everybody's extra knob, whether it's Flex or Elecraft, their extra knobs are expensive. So that's just what is. So the contest I ran with the 7610 this year, 160 CW, lots of QRM, just like 2 years ago. The 10 meter contest was a good test for weak signals and a good way to A/B. Like I say, every time I'm in a contest, whether it's nothing new, 2 new things, or if there's 2 new things, I'll have 3 operating positions set up. I will have the option to switch to a reference radio if I hear something that, boy, that's weird. What's it sound like on the reference radio? I'm not saying the reference radio is perfect. It's just something I'm used to. In this case, when I came to the selectivity issue, it's like, wow, there's a difference here, which you might not notice unless you can compare it. So I always have a reference radio and just change chairs, separate operating position. So I may have sort of caused this problem by my website is sorted all these 150 transceivers and receivers by close in dynamic range. And the numbers are big for the top 20. But you don't buy a radio just on one number. Just like you don't buy a sports car that can go 150 miles an hour on a drag strip, but if you go around a curve, it ends up in the ditch. I mean, it has to be, look at the big picture. So for me, fatigue's a big problem. I'm almost 75 years old. If the receive audio is cruddy or the AGC doesn't work right, and I haven't figured out how to set the AGC threshold, it wears me out. If the ergonomics are a problem, like it keep bumping the tuning knob when I'm adjusting the volume, that's not good. Does the speech processor work? Well, right now it's not working in the K4. They're working on it. You live in town possibly, most likely. Noise blanking and noise reduction might be really important on your choice of a rig. And that's something that's kind of hard to measure in the lab. Everybody's noise is different, but the noise reduction, noise blanking is a very much a wide range amongst the different brands. Well, since they're mostly firmware upgradable, are they firmware upgradable regularly with new features or bug fixes, or does it kind of like died out? So hopefully it doesn't die out on the radio you picked. What's warranty service like? I had a problem with Kenwood service. Now they've got some new company in New York. The one in California was terrible. So we don't want to send a rig in and wait for 3, 4, 5, 6 months. One of my friends in Alaska waited 6 months to get his radio back. That just doesn't cut it. Can we get parts once a radio is out of production? And what about LCD screens? You know, we aren't going to have 50-year-old radios that LCD screens will last that long. But forgetting LCD screens, can we get the parts we need, either at the factory or for ourselves? And then at the bottom line, do you enjoy using your radio? Are you a DXer, contester, rag shooter, FT8, whatever? It should be fun and not a struggle. So here's my email address, rob@nc0b.com, rob@nc0b.com. And you can send me an email, and I'm going to quit sharing and shoot it back to our moderator if you happen to have a question or two.
Thank you, Rob. That's just outstanding. Yeah, questions. Rob's got time to entertain them, so come forward.
I'm going to jump right in, Mike. So I've got a K4D 331, the serial number is 331. With the radio being out for 11 months, like you say, I mean, I'm an Elecraft fanboy. I think there's kind of a halo effect going on here. And so I'm going to air a little dirty laundry. And I'm curious, when you operated the latest K4D, and I've experienced this on 2 different K4Ds now, Did you notice in CW, and I'm sure it happens on the other modes, but there's something going on, and they know about this. Wayne knows about this. Bob knows about this. Bob BN6TV. They're doing something with the A to D and then the D to A conversion, where they're clipping and including some garbage. And so, especially when you have close, strong adjacent signals, there's garbage in that D to A. So you hear this popping noise, and it's maddening to me, coming primarily out of transmit on CW, semi-breaking, for example. Did you notice any of that as you operated on CW?
Right. And what's happening is there's, we'll just call it noise in the buffer. And
Yes,
like you say,
exactly.
you let up the key. You're not,
Yes.
like you say, you're doing full QSK. You would hope that when you let up the key, you're going to hear a real signal, but you're hearing what's left over in the buffer.
And I do not know why they spend time on silly features like a mini pan adapter display or a super silly prefix call sign lookup. I mean, there's so many features that I'm a contester kind of an oriented guy, and a little DXing obviously too. But I don't look at the radio. I don't care so much about that display. So that's good to know. I know they'll sort this out. So I that was my main question. I wanted to hear that confirmation from you.
So
Now, had you noticed the selectivity issue?
Oh, that's my next. Okay, if you want to keep me going on my little rants here. Yeah, I mean, and I don't try to bother Wayne or Eric, especially. He had a lot going on in his life. But yeah, the skirts are way too broad on the filters. And I can talk about the positives too. The CW filtering and the narrow filtering is just fantastic. I mean, it's a beautiful thing to behold and to listen to. But the selectivity is bad. I mean, you're hearing signals outside the skirts of those filters. If I'm hearing you there, what you described in your presentation, and I know in the next firmware release they're going to tighten that up. To me, it was like not having a super het for some reason, right? I mean, I don't have guys close to me at my QTH really, but yeah, absolutely. I wanted to throw my K3S or K3 back in at times. It just drives me crazy, the selectivity.
What my understanding is from Wayne is he'll have A or B. You can use what they have now, and some people like the sound of it.
Yeah.
Scott K0MD does, for instance. Or you can have the alternate, which is what I think will happen, but who knows? And I hope it's R29 or R30 or whatever. What puzzled me was we've had beta testers around for obviously at least a year, if not 2 years before it really shipped. And no one said a word about the selectivity or these other things that Ken and I brought up for almost a year. And hey, we're just two people using a radio for a few weeks. So I don't understand the beta group.
Well, I think there's been little blurps on the Groups IO reflector, but I think there's a propensity, again, it's kind of this halo effect. Nobody wants to, I don't want to be the guy that get on there and make a big stink, right? But we're talking about a $5,000 radio here that's been out for 11 months now. I mean, I'm hanging on. I think they'll sort it out. I can tell you my third thing that drives me insane, if you want to hear it.
Yes.
I guess I paid close to $6,000. It's a K4D, somewhere around there. I had to spend more money and get an external SDR to do a damn spectrum display. It's unbelievable. I mean, they don't have the, I know this is not a rant on Elecraft session here, but they don't have the IQ data and the bin data on the LAN port right yet, which is it's just mind-boggling. So I have to put in a receive loop with something like a SDR Play Duo or something like that, and then I reduce my receive sensitivity by 3 dB, which is trivial. It's just mind-boggling to me.
It's trivial on 160, but it's not trivial on 10 meters.
Oh yeah, exactly.
Now let me make one comment that I'm sure they could fix, but ICOM finally fixed what's now called scroll mode. And as you tune, let's say I've got like this 10 meter last weekend where mostly working DX, but I say I had the span for 50 kilohertz, plus or minus 25. And so the signals stay still and the cursor moves around. So I can watch the waterfall and all that. And then when I go to the edge, it jumps another 50 kilohertz, and I can see another 50 kilohertz of the band. In this case, that was most likely sideband as opposed to CW. But with the K4, when it jumps, if you're running it in that mode, it only jumps half the span. So I've got wasted half of the band scope and half the waterfall because it only jumped half. Now, other people may run it in fixed mode. I don't want to see that much on CW. I'm running 5 or 10 kilohertz spans. And so when it jumps, I want to see another 10 or another 5. So that's just weird too. But then
that's a little weird.
So whatever.
You find yourself centering it after that. And I'm good. I mean, to some degree, I know Bob really well in N6TV. He's tireless on his support side of it.
I don't think he sleeps.
Yeah. I mean, I haven't gone after this. There is kind of a propensity not to get too critical, on the group's IO, but some of these things are frustrating to me at this point. I'm hanging in there.
Okay. Well, let me just make a generic comment, because this is a problem on all brands.
Yeah.
And so take brand X. Someone makes a statement and then he gets flamed. Who wants to get flamed?
Yes.
Now, to some extent, I can make a comment and maybe a little less likely to get flamed, but boy, did I get flamed on the lack of audio. When I ran those 2 contests, the volume control was almost wide open the whole freaking contest.
Oh.
And finally, Wayne said, okay, at 4 ohms, you can only get 150 milliwatts out max. And at 8 ohms, you can only get 75 milliwatts out max. So they fixed it. But I just got
actually, it used to work, but then it was a regression. It was horrible. And then in R28, they fixed it. Yeah.
So I got flamed upside down and sideways. So no wonder people don't like to say something bad. So, okay, enough on the poor Wayne right now. So any other comments on anything else?
I'll just make one comment on the popping problem. At one of the firmware updates on a K3, I had exactly that problem on certain DSP bandwidths. And I got into a real-time debugging session with Wayne and, no, it wasn't Wayne, the other guy. Yeah. Eric. No, it was Wayne. I'm sorry. It was Wayne and who's the DSP guy? I can't remember his call. I don't think he works.
Lyle?
Yeah, Lyle. Those 2 guys. And this was exactly as you described. And it was exactly the same problem. And that was in a K3. And that was probably, I don't know, 6 years ago, I would say. 6 years ago, because it was my original K3, which is the oldest one. So that's a known problem for them in that architecture. So I'm really surprised it reared its ugly head again. Anyway,
a lot of the firmware code was ported over.
Yeah. Okay.
I certainly can talk about a lot of the good things too. There's plenty of good things. So.
Well, obviously there are people running them in contests and doing well. So that's reality.
Rob, I have a little different view on it than maybe Max. I've been very happy with the CW. I've used ICOM rigs for the last 20 years and run a lot of noise reduction just because noise gives me tremendous contest fatigue. And I was blown out by how quiet the K4D is with the bandwidth down at 50 or 100 hertz.
Oh, absolutely.
How selective it was. And, the only thing about CW that disappointed me with my K4, and again, I only had it for maybe 3 weeks to use because it came broken from the factory with a sub-receiver AF gain that turned out to be a defective pot. So it's coming back now to me for after repairs. But the APF is not quite as pristine or as helpful as the 7610 APF. I put on the IO group my comparisons with the ICOM radios, a good, bad, and ugly, and it was pretty well received. And I'll stick that into my EHAM review after I have another contest or two into the K4D. But I like the pan adapter as well. The APF is not as good as the 7610, but both are really good radios. The real question is whether the market will support two radios with similar features, one a little more sophisticated than the other, but the price points are twice, for someone with a station like mine that has, band decoders and bandpass filters and automated antenna switching, the ICOMs, you go through a lot of hoops with Hamation products to switch all that automatically. And with the K4, you have multiple USB or other outputs in the back that you can designate to each device, which will simplify some of that for me. And then I don't also have the problem that I have constantly with my ICOM radios, where I'll be doing a contest and suddenly I'll hear a click because the CI5 port had a collision or something with the band decoder, either one of the Hamation devices, and for a moment, for a half a second or so, the bandpass filter's out. So I'll miss something, and then it comes back in. And I'm hoping with the Elecraft radio, I won't have that problem at all. But it's a beautiful radio, and the other thing I'll say that's nice about it, it's lightweight. I mean, I have a 7300, a 7610, and a 7851, and they go up in weight and in price, right? Almost in the same proportion. The 7300, I've told Rob, it's the biggest $1,000 I've ever wasted, because once you've used the other radios, it's just not as good. But the K4D is so lightweight that it's so easy to move. I just appreciate the fact that it is so easy to just do things with. And I'm hoping that I can get it into my SO2R configuration in the near future, and then run it head to head against the 7851 and see if it can compete at that level with that radio.
No, so Scott, yeah, the CW audio on the K4D is just fantastic. I mean, maybe I came off very kind of, caustic there. It's just the popping in the skirts, which will be sorted out soon. I guess I felt like this was a forum I could be a little more open about.
I mean, reality, every radio's got warts. We have to recognize that. And it's unfortunate that people get flamed for making a statement. It is what it is. So Scott, really appreciate your input. Of course, we chat a good bit. And see, I happen to have two Hamation 2x8 in series, but they're not being run with band decoders. So I never ran into that. That's interesting as a problem. But of course, the CIV, if you're using the CT17, it doesn't like collisions. And there are some CIV switches out there, at least one, as opposed to we'll call it a hub. So I'm be interesting if that would help.
Yeah, my problem is all in the bandpass filters, it seems. And I will tell you that I'm not the most sophisticated software person, right? I'm going to get Doug to show me how to do some of this, I think. But with my 7851, the radio, the Shackmaster 8 switches the antenna automatically. But with the other radios, I use a different kind of band decoder from Hamation so that it doesn't automatically switch. Because there is one situation where I run separate monobanders on 10, 15, and 20, and then I have a tri-bander in position 8. And I can never use that radio with my 7851 because it's always wanting to shift it back to whatever frequency at antenna slot 4, 5, or 6. So there's some logic in not being too automated here.
Well, that in my case, I have two Yagis on 10, 2 on 15, and 2 on 20. And it's like two different bands. You got one pointed to the Caribbean, the other one to Europe or JA or wherever. And so you just click, you're going the other direction. So I wouldn't want it automated either in that case. Any other questions about anything else? Rigs, testing?
So Rob, you seem that I've read others saying that for its tremendous rankings on your list, that the Yaesu FTDX10 may not have the same utility as the Kenwood 590 as an inexpensive, highly performing contest radio just because of the ergonomics. Would that be a fair assessment based on what you said today?
I think so. I mean, it wasn't fun to run it. It worked with, I never lost a contact because of it. The selectivity was fine. The APF adjusted the way I wanted. It was fine. It had no trouble integrating with N1MM. I'm not a sophisticated operator. I do S&P. And so, nothing unusual for the average, probably contester. I know Steve N2IC was here a moment ago. He might want to comment because he's the one running the pair of 590s that, until the 7300 came around, realizing it's not the top of the line radio, but the 590 series was the biggest bang for the buck for what? Almost 10 years between the S and the SG. Heck of a radio.
I'll jump in there on the FTDX10. I have one. I absolutely love it. I'm mostly a CW contester, and as such, I use N1MM, and I rarely have my hands on the radio. And I have no problems with the ergonomics. Furthermore, it's my first, well, actually I had a 7300, but I don't notice any difference in the band scope. I love everything about the FTDX10. And I'm about ready to buy another one for my SO2R setup. So that's my input.
Well, certainly all have different opinions and different way we use the radios. And you know, for $1,400, I mean, if you're saying, well, I need a radio that can take to field day that isn't going to wilt with a guy on sideband when I'm on CW, well, there's the FTDX10 certainly will shine there, and the 7300 would not.
Speak up, guys. It's a great chance to pick Rob's brain.
Uh-oh, my brain ran out.
Yeah.
Rob, this is Harris, K9RJ. Can you just comment a little bit on the quality of the respective transmitters?
CW or sideband or what?
Both.
Okay.
Both.
Well, as I mentioned, if you've got one that you can adjust, go in and adjust the rise time. Now, someone just asked me the other day, well, what, I can't find an adjustment on the K3 or the K4. Well, they never let you screw it up and pick 1 millisecond. So it was fixed with a sigmoid shape and about a 5 millisecond rise time. K4 may be a little bit faster than that. Maybe they should slow it down a little bit. But so the biggest difference is how you can screw it up. On sideband, we're all pretty much stuck with less than optimum splatter. And in one of my slides on another presentation, the difference between the patchy with pure signal is just like you saw in that one with the on 20 meters, that it's even more dramatic. So I don't know that there's any quick fix. I mean, the 13.8 volt rigs, which are most, are not going to be as clean as a 50 volt rig. But then in the case of the 101 MP, if you run any ALC and run Class A, you really want it super clean, well, then it ruins Class A. So that's kind of the deal there. Flex has talked about pre-distortion now for 8 or 10 years. And it's on the list, and some people say it's imminent, other people say it's not. I don't know, obviously. Elecraft says they're going to have it. Most all the newest amps have a sampler built in. Now, if you got a L4B or a SB220 or whatever linear amplifier, you can put a sampler on there. So when you have a rig that can do pre-distortion, you can make it work with any amp. Of course, you want the amp in the loop because we can clean up the amp in addition to cleaning up what's in the exciter. So there's not much difference aside from pre-distortion on the splatter characteristics. And you just need to click in your menu 6 or 8 milliseconds and don't do this 1 and 2 and 3 nonsense. Now, you guys that are really great CW ops probably have other comments as far as the keyers and weighting and other things. I know the TS890S, it comes with a fixed initial delay in what keys the amplifier, because you don't want a hot switch. So if you thought, well, gee, I need to put in 15 milliseconds of delay so I don't hot switch my AL80B, well, it starts truncating CW, but it already had 15, and you didn't probably need to add to it. So there's an issue there with timing on the 890S in respect to affecting CW when you're adjusting your delay for the amplifier. Anything
other
else?
questions? Yeah, any other questions, guys? Okay, Rob, really have to thank you tremendously for fantastic presentation. It's good information. I think everybody appreciates hearing a little bit about the K4D. Some of us are in a wait mode to see what shakes out there. I've got experience using the 7610 at N6WIN's place in ND7K in contest, and I found it to be pretty superb radio. But I haven't used I've used K3 extensively through K at IA's place and others, but K4D is something I'm interested in the future. So before we let Rob go, anybody else have any questions?
So Lee, in order to keep the presentation to a reasonable length, I did chop out some spectrum analyzer screenshots of several different rigs, just giving examples of the variation. I sent that little PDF off to your club. And if somebody wants to request not only the PDF of the main presentation, but just tack that on, it's available. And if anybody has a question, just rob@nc0b.com.
Yeah, and I've got those. Rob sent them to me. So I may see how I can post them to the, possibly to the AOCC website. I can let everybody know on that. Or if you have questions, you can always email me at mike@kc7b.com and I can send them to you directly. But Rob, again, thank you.
So is this going to be up on a, as a video?
Yes, it is.
Okay,
We've recorded a video.
okay, so send me a link when it's up.
You got it.
Oh, yikes, all my wonderful comments.
Well, hopefully every OEM can take input and say, okay, we're going to fix it. And certainly with this, everything being flashable with firmware updates, this is down the road.
Yeah, I didn't say anything they don't already know about.
Right. Well, nothing I said, Wayne's had this sometimes since last May, or maybe had it since December. So, I mean, we need a strong US manufacturer in Flex and an Elecraft to keep the Japanese manufacturers on their toes.
Thanks, Rob.
All right, have a good night.
Good night, Rob. Thank you all who's showing up, especially the guests from around the country. We appreciate the time you took to listen in. And we'll try to put something like this together again for the future and let everybody know.
All right, 73.
Good night to all of you.
Thanks,
Bye-bye.
Mike. Thanks, Rob.
Thanks you.